The Linux boot sequence involves a series of steps that occur from the moment the computer is powered on until the operating system is fully loaded and ready for user interaction. Here is a simplified overview of the Linux boot sequence. 1. BIOS UEFI. When the computer is powered on, the basic input-output system, BIOS, or Unified Extensible Firmware Interface, UEFI, initiates the boot process. This firmware performs hardware checks and activates essential components like the CPU, RAM, and storage devices. 2. Bootloader, or GRUB. The BIOS UEFI hands over control to the bootloader, commonly GRUB, Grand Unified Bootloader, in many Linux systems. GRUB loads the Linux kernel into memory and provides the user with a menu to choose from different kernel versions or boot options if applicable. 3. Linux kernel. Initialization. Once the kernel is loaded, it initializes essential hardware components, sets up memory management, mounts the root file system, and establishes communication with peripheral devices. 4. Initramps, initial RAM file system. In some cases, the kernel may use an initramps, a small initial file system loaded into RAM. Initramps contains essential drivers and tools required for the kernel to identify and mount the root file system. It is particularly useful for handling complex storage setups or situations where the kernel needs additional modules to boot. 5. init process. The init process, or its successor, such as systemd, is the first user space process that the kernel launches. It has the process ID, PID, of 1 and serves as the ancestor of all other processes. The init process is responsible for initializing the user space and starting system services. 6. Run level or target. The init process determines the system's run level, or target in systems using systemd. The run level defines the system state and services that should be active. For example, the default run level for many Linux distributions is multi-user target or graphical.target, depending on whether the system is meant to start in text mode or with a graphical user interface. 7. System services and daemons. The init process or systemd initiates various system services and daemons based on the run level or target. These services include networking, logging, and other essential components needed for the system to function. 8. Login prompt or graphical display manager. Once the essential services are started, the system presents a login prompt on the console or initiates a graphical display manager, such as GDM, LightDM, or SDDM, for systems with a graphical user interface. Users can then log in and start interacting with the system. 9. User session. After a successful login, the user's shell or desktop environment is launched, providing a complete user session. This boot sequence may vary slightly depending on the Linux distribution and specific configurations. Additionally, modern Linux systems often use systemd as the init system, which has replaced the traditional init process in many distributions. The systemd initialization process has its own set of targets and units for managing services and dependencies.